Welcome back. My name is Segun, and we're in the part 4 of this series of Blender animation. So today we'll be talking about Blender icons. And the next thing we're going to look at here is like origins, location, transforms. This has to do with how your object is being positioned in your 3D space, but I'm not going into that right now. I'm going to go into our render engine. Now, Blender 2.93 comes with 2 basic render engines, and I'm going to share with you what those 2 render engines are. The first render engine is called the Cycles Render. Now, the Cycles Render is a super realistic render engine that it's a bit unbiased. When I say unbiased render engine, what I'm saying is that render engine, whatever it sees, is going to actually give you that particular object in a realistic view. And Cycles Render is a bit synonymous to render engines like Anode Render, Octane Render, we have Redshift render engines, V-Ray render engines, Anode Render, so many render engines. All these render engines actually differ from one another. So basically that's what makes it different. The next render engine we're going to look at over here is the eevee. Now the eevee was created because of artists who want to render complex scenes, but they want that scene fast and quick to render, because if you're using cycles may take a long time to render your frame, but it comes out realistically. Why? An eevee is not super realistic, but it renders an object very fast. So that's why we have those 2 render engines. And there are a lot of product designs that I've worked on that have used the eevee render engines. Like one of the product designs I've worked on is this one showing on the screen, which has to do with a mobile design I made for a company, and these were like I had to use a eevee render engine because they needed the job very faster, and so the eevee render engine was just perfect for doing this. We're going to switch back to cycles because we're using cycles. The next thing you would see here is, apart from the supported, is the CPU. Now I'm going to explain this. This is something controversial that a lot of people don't actually understand how it works. CPU, when you enable your CPU, what you're saying to the render engine is, look, I have my central processing unit RAM rendered, enabled. Make use of this. Meaning if it's going to render out this image, it's going to use your RAM power to render it. Meaning that it's not using your GPU power to render. The reason why it's not using your GPU power is because your GPU power is not enabled. Now, for some people who have like 32 gig RAM, CPU power is the best way to go for rendering your object, because you have a stronger and bigger RAM compared to when you have a 4 gig NVIDIA graphics card. It's different. So if you have like a 32 gig RAM, it's easier for you to use it to render, and it will become a bit faster compared to you when you use your GPU. On the downside, let's move to GPU. If you enable your GPU, what you're saying is, hey, my GPU is strong. Maybe, for example, I have 1080 Ti NVIDIA graphics card 11 gig times 4 on my system. What I am saying is, hey, and I enable it, I'm saying, hey, look, use my GPU to render. Immediately, the system is going to make use of your GPU doing the path tracing in rendering out your 3D objects. So we're leaving it back on CPU. The next thing here under this icon is we have render. Now render here is something that you have to take note of. If you check our last render we did, there were some things that made the render not look perfect, which is actually the noise. There were a lot of noise in the renders, and we don't want that noise in our render. So what you could do, you could bump up the render power to, like, for example, I could bump up my render power to like 600. Now when I bump up my render power to 600, what I just did to my system is I've actually added pressure. So I'm going to render out something and we'll let it render underneath. I've added more pressure, and it's going to take a long time before it finishes rendering a frame. Now, because now we're going to close this. Now you find out that our object that we're rendering has a lot of grain. Now, if you look carefully, you find out that why bumping it up, the higher you bump it, the lower it reduces the grain. So what it's trying to do is taking time to process and reduce the grain in the image. That's what it's doing here. You could see that it's getting clearer and clearer because I bumped up the render setting there. But we don't want that. We're going to leave that underground and let it work. We don't want that. You actually want that, but you don't. There are other ways you can reduce noise. So I'm going to explain that. We also have, I wouldn't advise you can always change this to 0. I normally take it to 0, the viewport, when I'm working. You have adaptive sampling. Under adaptive sampling, you could do other things. You have denoising. Right here, you could denoise also. And under here, I don't normally touch all these advanced parts. Light parts, you could change or determine how you want the light to bounce. But this is an advanced stage, which we'll check that. We have volumes. We have hair. Now, if you have hair simulations, these are where it actually comes in play. We have simplify. We have motion blur. If you're working on an animation and the character is moving, you can use a motion blur. Then you have depth of field, just like your regular camera where you have a depth of field. You could set it that, okay, I want my focus to be on the robot and everything behind the robot is in blurred field. That's called depth of field. So you're trying to add a depth of field. So you could do that from the film and motion blur and everything. Here you have other stuff like transparent. Transparent is if you're trying to create a transparent background. You have performance, but all these are like the advanced stage, which you don't actually need them now, basically. The next one we're going to move to is the size and resolution. Now, the size here I have is 920 by 1080, which is a standard 1080p full HD camera. You can actually set it, maybe you want it to be 920 by 720 or whatever. You could change it from there, the aspect, you could do that, XYZ. This frame starts, frame ends. This has to do with the timeline down here. This basically when you do your animation and you're doing your keyframe and you want to render out, you're basically going to tell the system that I want you to render from maybe frame 1. Like for example, if I say I want to stop at frame 10 and I type in 10 here, you find out that right here it just stopped my render from 1 to 10. So then you can put it back to 250. You see, so it makes the timeline longer, meaning that this is the length. So this will be explained when we're doing animation more. We have frame rate, which has to do with 24 frames per second that I explained in our introduction video on how to learn animation. So these are things we're going to learn practically. Then we have where you want to render your image to maybe eevee, JPEG, RAW, whatever, PNG, sequences. That's that. But these are like later stages we'll do that. The next thing we're going to look at here is we're going to look at passes. Passes like basically used for VFX and so on. Maybe you've rendered one thing, you want to now create them in passes. The specular, the gloss, the transparent, the illumination, and so many things. The AO, you want to kind of separate them. This we use passes basically. Another thing you're going to use here, I won't talk about this until we have a character here that we can use to explain. The next one you have is an HDRI. Now HDRI is high dynamic range images, which basically implies you maybe for VFX or for anything you shot in a place and you want to have the high dynamic range, the reflection lighting of that environment. That's when you use an HDRI, but you can also use it for so many things, which I would explain in our subsequent classes when we get into full animation. I'm going to leave this for now. Then I'm going to go to right here, transform. Like I explained, transform. If you also want to get more about transform visibility, you can press N and you have some stuff here, like here. So we're leaving that.